Greetings, fluid mechanics enthusiasts. Well, on this video, I would like to talk about what it actually means to be an engineer. It doesn't matter if you are a civil engineer, or a mechanical engineer, a chemical engineer, aerospatial engineer, so on. Uh, It doesn't matter if you are an employee or you are an entrepreneur, you have your own business. It doesn't matter if you're a teacher, you're a professor, whatever. I'd like to talk about what is the meaning of being an engineer in the sense that what is the significance? What is the significance to ourselves as individuals and to society and to our peers, of course. To put it very simple, an engineer is someone who solves problems using logic. Okay? So the classical example would be, I want to move from point A to point B, right? But there is a river between these 2 points. So how can I move from point A to point B? If you're an engineer, you would try to use reason and logic to obtain the best solution to this problem, which of course is a problem of bridge construction. Apart from being a problem solver, an engineer must of course always aim to solve a problem. We want the maximum security to our engineering problem, to our engineering solution, but at the lowest cost. So if you put too much effort in providing a secure solution, well, you're prioritizing safety. Your solution would be very expensive. It is not economically viable. Okay? But if your solution is too cheap, it will be not a safe solution. So as an engineer, we are looking for a solution to a well-determined problem that maximizes safety but minimizes cost. So you can put this to variables in a graph, and when these two lines encounter one another, that's when we have the best engineering solution to our problem. Of course, some engineering problems required higher safety criteria for them to be solved. Like if you're designing a nuclear power station, it must have a very high safety factor. So that, of course, will make nuclear power stations very expensive to build. Right. So, on the other hand, if you're building a simple house, its safety factor will be a lot less than nuclear power station, right? You can think of the safety factor as an indirect measure of how many people would be affected if your engineering project fails, right? If your engineering design fails. If a nuclear power station fails, hundreds, thousands, or maybe even millions of people would be affected by its failure. Okay, so it must have a high safety factor. On the other hand, if a house fails, if it blows up or fall, due to wind conditions, tornado, weather. Perhaps 1, 2, 3, up to 4 people would be killed, right? So that, of course, has a huge impact on the economic, on the cost of building a house. Okay, so if we aim, so in a hypothetical scenario, if we aim to build houses that are as safe as the nuclear power stations, that house would be so expensive, but so expensive that no one will be able to buy it. Okay, so we can make houses as safer as a nuclear power station. And of course, we can't make nuclear power stations as cheap as a house. So remember, as an engineer, we have to look for the maximum security at the lowest cost. But of course, we can changes curves from prioritizing more safety than costs, and or prioritizing costs more than safety. And it will be greatly dependent on the type of engineering project you are dealing with. So that is our main. Uh, I often consider that as the main attribution of an engineer. You're you're looking for you're looking for contracting an engineering for a job, right? So you say to the engineer, I want to go to Mars. Is it possible? The engineer would say, well, in engineering, everything is possible. But at what cost? Of course, if you want to go to Mars, you will have to, you need to have a very great budget for this project. That's what Elon Musk is about to do, right? He has a great budget, and even with that big budget, he's struggling very much to go to Mars. But it is possible. It is technically possible. The matter is, how much does it cost? How big is your budget that you are providing? You are interested in investing on this project, right? If you provide a good budget, you can make almost any engineering project possible, right? Of course, it must be physically possible, right? Let's say you want an engineer to make a time travel machine. Well, at least today we know that we can time travel. At least not in the past, but we can time travel to the future. But for that, we'll need to travel at the speed of light. And for technical reasons and for physical reasons, we don't have a physical basis for that. But once a physical basis is provided, we are capable of doing such things, right? Another aspect of being an engineer is that an engineer is someone who is one foot on science and the other foot on empirical knowledge. So the engineer is half a scientist and half a technician. Someone who is able to concretize, to make ideas concrete, to take scientific ideas to the real world, right? Before engineering creation is possible, the physical basis, basic physics laws and fundamentals must be established in order for that to happen. For example, before Thomas Edison invented the light bulb, we already had a good understanding of electromagnetism. Another example would be quantum physics. After we developed quantum physics, we were able to develop great tools such as radiotherapy and other nuclear medicine advances. So, physics provide the basis for engineering inventions and solutions. So, a good engineer must know physics. Apart from that, an engineer must have a good basis of mathematics. Well, why mathematics is so important to an engineer? As I said before, an engineer is someone who will provide a rational and logical solution to an everyday problem, right? It would make our lives easier. That's what an engineer does. So in order to do that with reason and logic, an engineer must use the greatest logical and reasonable tool that was created by mankind, which is mathematics. An engineer must be able to measure things and make relationships between these measures. So that's what the mathematics are for. So as engineer, we will derive laws, equations that will serve as a design tool for our creations. Take for example reinforced concrete. There is an equation that we engineers, in particular building construction civil engineers, use to calculate the amount of steel rebars needed in a concrete beam, which is of course a mathematical equation. So mathematics is a crucial discipline for engineers. Apart from that, physics and mathematics, which of course will take a role on the safety part of an engineer design. There is the science of economics, engineering economics, and economics in general. Because we as engineers must know how to quantify costs, costs in material, costs with personnel, costs with labor, and so on. And avoid conflict between an affordable engineering project and a safe engineering project. So I'd like to know in the comments what do you think that is the essence of being an engineering? What being an engineering means to you? Okay, so don't forget to like this video, to share this video with others, and subscribe to this channel. Okay, see you next time. Bye.